Welcome back to the channel. Today, we are diving into the world of renewable energy, the power sources shaping our future. From sunlight to wind and flowing water, let's explore how clean energy is transforming the planet. Electricity produced from any source, which does not pollute environment and sustainable for our future generations. Source required for generating energy broadly divide into two types: renewable energy sources and non-renewable energy sources. Benefits of renewable energy are its environmental benefits, which include reduced emissions and cleaner air, its sustainability, as it comes from inexhaustible sources, its role in increasing energy independence by reducing reliance on imported fuels, its potential for economic growth through job creation, and its ability to lead to lower energy costs over time. Solar energy is the most abundant source of energy on Earth, fueling the plants we use for food and fuel and powering the wind and weather in our skies. Today, solar energy is one of the fastest growing sources of our electricity. And new improvements are making solar cells even lighter, cheaper, more powerful, and more flexible, so we can use them in more places. Solar energy is radiant energy from the sun. In the initial phase, raw silicon is extracted from the quartz and purified using a chemical process. The purified silicon is then crystallized to form large chunks, which are further sliced to create thin silicon wafers, 200 to 300 micrometers. These pure thin wafers are then treated with phosphorus or boron to create p-type or n-type semiconductors. This forms a texture and enhances their electrical properties. After that, the wafers are coated with an anti-reflective layer to reduce light. By connecting these cells parallelly or in a series, it is then encapsulated like a sandwich with protective materials such as glass. An aluminum frame gives the encapsulated cell structural support, and the back sheet at the rear side provides protection and insulation. Finally, the assembled panels are tested for efficiency and durability before being packaged and shipped for on-site installation. One of the major elements of solar panels is solar panels themselves. The role of the panel is to generate electricity. No matter what type of solar panel you are using, the role of every solar panel is the same. Generally, solar panels are made up of solar cells made of silicon that are wired together to make solar modules. Solar inverters are the mechanisms that make the conversion of the direct current, DC, produced by the solar panels into the alternating current, AC. The major drawback of solar panels is that they do not generate energy, or we can say that they become useless when the sun goes down. The cloudy seasons are the major hindrances of the energy generation tool. A lead-acid or lithium-ion battery stores solar power generated during the daytime and releases it in the dark. A power controller is required to monitor the charging of the battery. These controllers come between the panels and the battery. Such controllers are typically fitted with a small LED light that reflects the state of the charging battery. Thus, adjustments are made to the power that flows inside the battery. Now we learn about wind energy. The important machine required for harnessing energy from wind is wind turbine. Parts of wind turbine are rotor blades, gearbox, generator, nacelle, power cable, and tower. Basically, the wind's kinetic energy is converted into mechanical energy by the rotor. The electric generator converts the mechanical energy into electricity. A transformer transfers the electricity from one circuit to another. The process is quite simple. The rotor is activated by the wind. Its rotation is transmitted to an input shaft that powers an electric generator. This so-called yaw system enables the nacelle to be positioned based on the direction of the wind. The rotor starts working only when the wind speed is greater than 10 km per hour, while the wind turbine shuts down at speeds of over 90 km per hour for safety reasons. Turning water into electricity? Sounds like a magic trick. It's called hydropower, and it's the largest source of renewable, clean energy in the worldwide. How does it work? It's simple. Using the power of the flow of water, we can capture kinetic or moving energy. This movement of energy can be used to physically move other objects, like a turbine. Turbines and generators convert the energy and power of flowing water into electricity. That electricity is then fed into the electrical grid to be used by you and me in homes and businesses. The diagram labels significant parts: reservoir, intake, penstock, turbine, generator, powerhouse, long-distance power lines, and river, depicting the process of electricity generation in a hydroelectric dam. It shows a reservoir leading to an intake structure where water flows through a penstock down to a turbine. The turbine is connected to a generator located within the powerhouse. The generated electricity is then transmitted via long-distance power lines. If you've ever observed an erupting volcano or the geysers at Yellowstone National Park, you've seen geothermal energy in action. The Earth's crust is made of rocks and water. Deep below that is a layer of hot, molten rock called magma, which is even hotter than the sun's surface. The heat just over 6 miles below the surface contains 50,000 times more energy than all the oil and natural gas resources in the world. Releasing a small amount of that heat in the right way can create electricity. A well drilled a couple of miles deep can capture the rising hot water and steam. That steam spins a turbine. Hot water is pumped from an underground reservoir to the surface. At the surface, the change in pressure causes some of the hot water to flash into steam. The steam drives a turbine and generator to produce energy, electricity. The remaining water and condensed steam are cooled in cooling towers and injected back into the earth via an injection well to replenish the reservoir. Geothermal energy is a renewable, clean, and consistent energy source. Here's how it goes from waste to watts. Trees and plants absorb energy from the sun through photosynthesis. The energy is trapped inside until the organic material is converted into other products that are used as sources of energy and materials. There are several kinds of biomass such as agricultural residues, purpose-grown energy crops, and wood. For hundreds of thousands of years, humans have used wood. Biomass also includes wastes, and there are processes that work for many types of waste biomass, like animal waste. That's right, poop. Believe it or not, poop can be used to make electricity. Gut, a digester has bacteria that eats waste and turns it into methane gas. The methane is burned to heat water, and the water creates steam. The steam creates pressure that spins a rotor inside a turbine. The turbine powers a generator, and the generator produces electricity. That's it. Methane can also be captured from landfills. When biomass decomposes, it emits a gaseous product called biogas. Biogas is rich in methane, and after some cleanup and upgrading, the methane gas can be captured and burned in the same process to make electricity or to heat your home and cook your food. Biomass can also be used to make products like polymers and plastics that are recyclable or biodegradable. Together, we can power a cleaner future. If you learned something new today, don't forget to like the video and subscribe for more renewable energy insights. See you in the next one.